This is the review video for Monday, which is the sub day. I won't be there. I decided what you really need to do is practice some multi-step equations and solving for variables. So just as a reminder, when we're solving an equation, we're solving like a multi-step equation for a variable, right? Like if we had x plus 1 equals 2, when we solve this equation, what we're really doing is we're saying, well, what number does x have to be to make this equation true, right? As in, what something plus 1 is equal to 2. Well, I mean, you all should know this, right? In this case, we actually just would subtract 1. I'm sorry, got messy. Minus 1, minus 1. What we're left with is just an x on one side equal to a 1 on the other side. And that makes the equation true, right? If we rewrote this, instead of an x right here, we said a 1 plus a 1, well, that's 2, right? 1 plus 1, 2 equal to 2. The key is, this is a true statement, right? 2 is equal to 2. We know it's right? In this case, we found there's only one solution to this whole problem, and the only way that this original problem over here, x plus 1 equals 2, the only way that that actually makes a true statement, right? That this equal sign belongs there is if x is equal to 1. If x is equal to 1, then the equation is true. Both sides are worth 2 units. Okay, that's the first thing. So let's do a couple examples. So the first kind of problem you're going to see is relatively simple, and you're going to see probably like terms on one side and then a single thing on the other side. And so what you need to recognize with these is, well, I have a 2p plus a 4p equal to negative 6. Well, 2p is just p plus p, right? It's 2 p's. And then 4p is just p plus p plus p plus p. Well, if you add those together, you end up with 1, 2, 3, 4, 5, 6p, right? We're just combining, and we can do that because they're all the same kind of term. So 2p plus 4p just becomes 6p. We didn't change anything on this side, right? This side is still equal to the same amount, 2p into 4p. We combined those like terms together and got a 6p. And so that is still equal to negative 6. And those combining those like terms, that's worth doing, because when we do, we can see a lot. We can see really we don't have much left to do, right? Instead of 6p equal to negative 6, what we need to know is what one single p is equal to. So we divide this side by 6, and we're left with, right, any number divided by itself is just 1. So we're left with 1p on this side. You can write that 1 there if you want to, but you don't have to. And we have to maintain balance, right? This equal sign in the middle means balance. Anytime we change the value on one side of the equation, we have to change the value in the same way on the other side of the equation. So if we divide the left side by 6, we must divide the right side by 6. Negative 6 divided by 6 is just a negative 1. There we go. We solved it. And if what we kind of started with in the beginning is true, what that tells us is that when p is equal to negative 1, the whole left-hand side will be equal to the whole right-hand side. And so when I tell you to check your answers, that's what I mean, check your answers. So we know if we were to rewrite our equation from the original problem, 2, and then instead of a p, we'd write the negative 1, plus 4, and again, instead of a p, we'd write a negative 1. And if we did things right, that should all be equal to negative 6. So let's see. We have 2 times negative 1 is just negative 2, plus 4 times negative 1, which is just negative 4. And if we did everything right, that should still be equal to negative 6. And you can do the math. I already did it. We'd end up with negative 6 equal to our original negative 6. That's a true statement, right? This equal sign is correct. Negative 6 is equal to negative 6. We're done. We got the answer right. We can move on. All right, this one's a little different, and this one gets a lot of you. We have just one thing on the right or on the left-hand side, and that can get a little tricky, but this is actually an easy one. Trust me, bear with me. the first thing you need to notice, right, the first step when we're solving a two-step equation or a multi-step equation is to get all the terms that contain the variable on one side of the equation or of one side of the equal sign, and then get everything else over onto the left-hand side. And so we're close already, right? There's only one term that contains a variable, this negative 3x right here. That's already by itself on one side. We just need to get rid of this negative 3 and this positive 3 that are keeping it company and getting in our way. And the good news, right? Negative 3 is really just a negative 1 3 times, right? And a positive 3 is just a positive 1 3 times. Let's just make that a little more even. There we go. So if we had a negative 1 and a positive 1, well, that's just 0. If we had a negative 1 and a positive 1, that's also just 0, and a negative 1 and a positive 1, that's also just 0. So because they're like terms, because they're just a pile of negative ones and a pile of normal ones, there's no x's, there's no nothing in there, a negative 3 and a positive 3, well, that just goes away. That just equals 0. So we can cross those two out and we can rewrite our equation, right? 15 is now just equal to a negative 3x. We didn't have to do anything to the left-hand side of the equation because we didn't actually change the value, right? A negative 3 plus 3, that's just equal to 0. So all we did was combine like terms, right? Just like up here above, we added the 2p and the 4p. We took those two terms and mushed them into a single pile. We're not changing the value on the right-hand side of the equation. We're just combining like terms. So we did that. Now we have 15 equal to negative 3x. And well, that's the hard part done. We don't want negative 3x equal to 15. We want a positive 1 equal to something, right? So we divide this side by negative 3. We do the same thing to the left-hand side to maintain balance. We bring our x down. We see that x is, I'm sorry, I lost my place. We see that x is equal to negative 5. And I'd encourage you to take a little break and go over here and try and plug it back in, right? You could rewrite the equation. 15 equals negative 3 minus 3 times negative 5 plus 3. And if you evaluate following the order of operations, you should get a true statement. That is, everything on the right-hand side should end up being equal to negative 15. All right, I think we just got 2 more to go, and then I'll let you out of here. This is another situation where the first thing we need to do is we need to combine like terms, all right? We have a 2n and a negative 3n. I need you to recognize that those are just 2 piles of n, and you need to combine them before you do anything else. So a 2n minus 3n's is just going to get us a negative 1n. So I'm going to write it as negative n. You could write negative 1n with that little 1 right there if you wanted to. So we took care of this side. And there's not really anything to combine. I can't mush a negative 5 and a negative 2n together. They're 2 different things. The negative 5 is a pile of negative 1's, whereas the negative 2n is a pile of negative n's. They're 2 different things. I cannot mush them together. So just rewrite this down here. And what else do we have to do? Okay, well, let's see. We need to get all the variables on one side and everything else on the other. So, we already have this negative 1n over here by itself. Let's deal with that. Let's take this negative n on the left-hand side, add a positive 2n, do the same thing on both sides. Well, a negative n plus a 2n, that's just 0, that goes away, so we're left with a negative 5 on the left-hand side. And if we took a negative 1n and added 2n to that, we'd be left with just an n. That's it, right? We have 1n equal to negative 5, and we're done. Last one. This one has a distributive property in it, right? The distributive property is just how do we get rid of those parentheses, right? So all we have to do is get rid of those parentheses. So we've talked a lot about this. I'm just going to remind you about the steps. We would distribute this 2 over all the terms inside the parentheses, right? Right now, this whole thing says we have k plus 3 2 times. So let's take it 2 times. Let's take 2 times k. That will give us just 2k. And then let's take 2 times 3, and that will just give us 6. Now, the important thing in here, right? We took k plus 3 2 times. We didn't change the value of it in any way, right? We could also have written it k plus 3 plus k plus 3. It's the same thing. We could write those either way. All we did is just took these two k's, this one, and got 2k, and we took the 2 3's together, this one, and got 6. We didn't change the value in any way. The left-hand side is still exactly the same value, it's just rearranged in a way that we can deal with it. And so because of that, we don't have to do anything to the right-hand side. We can just bring down the terms so we can keep solving. All right, now from there, we're back to our normal step. Get all the terms containing variables on one side of the equation, get everything else on the other side. And you just pick what's easiest for you. Sometimes it doesn't actually matter. You can do anything you want now as long as you do it to both sides. That's what I want you to remember. So for whatever reason this time, I'm going to say I want to get all the k terms onto the left-hand side. So I'm going to subtract 5k from here. I'm going to do the same thing over on the left-hand side to keep balance between the two equations. Positive 5k plus a negative k, that's just 0. So on the right-hand side, we're left with a 9. And let's see where we are from there. From here, we could say, well, 2k minus a 5k is going to just be a negative 3k. Oops, I need to leave myself more room. Negative 3k plus 6. All right. We're almost there. From here, we just need to get all the terms containing k on one side, everything else on the other side. So the only thing left is we have the negative 3k on one side, we need to deal with the positive 6. So the opposite of positive 6 is a negative 6. Make sure we do that on both sides. If we have 9 minus 6, we have 3. Positive 6 minus 6, well, that's just 0. We're left with a negative 3k. We're almost there. From there, we don't want a negative 3k. We want just a single one positive k equal to something. So divide this side by negative 3. Anything divided by itself is just 1, right? So we're left with 1k on the left-hand side. Do the same thing on the other side. Positive 3 divided by negative 3 is just a negative 1. And we're done. I went kind of quickly. I just talked through the steps. I gave you an example. Every example in this video is similar to the kind of problems that are on your review worksheet. So you should watch them one at a time as you need them. When you see something with parentheses, watch the parentheses video and just work through the worksheet as best you can. I don't necessarily need you to finish it, but I need to see that you've actually been trying to get some work done during class. All right, I'll see you all on Tuesday.